I'm a software engineer and data scientist at Microsoft. And for about the past, I would say around 20 years, I've been working in C#. And then around 4 years ago, I started doing data science, machine learning, and all that good stuff. So I was sort of forced into this world of Python. And what I'm going to talk about today is my journey basically to production systems in Python and a couple of things I learned along the way. So hopefully, no matter where you are in your journey, whether you're just beginning or whether you've been doing this for a long while, I'm hoping to give you at least some tips and tricks. And I am quite opinionated, so in some cases I will say, I think you should do this. It doesn't necessarily mean that you should, but at least hopefully this will give you some input for what you could do. So my first part of my journey was to set up a really good dev environment. And this actually took me quite some time to get it right. In the beginning, I was working in notebooks, which I'll talk about later as a no, we're not doing that. But what I was also doing was I started working a lot in VS Code. So right now, actually, I'm using two main development environments. I'm using pycharm from JetBrains and VS Code from Microsoft. So you can kind of compare these for C#, like how and these two Visual Studio versus Visual Studio Code for C#, where pycharm is this bigger, full-blown IDE with with everything you need, including like test runners, built-in code style validation and things like that. But it's a little bit on the heavier side versus VS Code, which is very modular, and you can install it on machines where like very quickly. However, you do need to install a lot of extensions. So right now, my current mode is that I use pycharm most of the time, and I use VS Code specifically when I want to connect to a remote data science virtual machine or something like that. If you do want to work in pycharm, I think you can download it for free. Martin can probably answer that in the chat if that's not correct, but it's a really great environment that takes care of a lot of like making sure you have everything set up. Visual Studio Code, on the other hand, like I mentioned, needs a little bit of caretaking to get it to where you want to be. So these are some really good extensions that I recommend for Visual Studio Code. The Python language extension, which helps us set up everything code related to Python. So for example, configuring your test runner, selecting your linter, which I'm going to talk a bit about what I'm using as far as linters and things like that. And also in the third section here, you see selecting your interpreter. So that's your python.exe, depending on if you want to use Python 2 or Python 3, and also if you want to use virtual environments, which I'll talk about. Then in Python, if you set up the Python extension, if you set up a linter like Flake 8, you also get sort of like information about what you should change to make sure your code follow the PEP8 code style. And this is something that actually pycharm is doing by default, so you don't have to install anything. It automatically sort of gives you validation as far as how your code should look. So if we look at pycharm, it would look like this, and automatically it would then tell us information about things that we're doing wrong in our code and should change. The next extension that I really like is one that's called Pywrite. Pywrite is an extension that helps us with type hinting. So Python in itself doesn't have strong typing, but you can include type hinting as you see here, so telling the interpreter what your parameters are, what types they are, and things like that. But we'll get into a lot more of that later. This extension, trailing spaces, is a really good one if you work with something like Flake 8 as a linter. So this gives you information about like where you've actually put in some spaces that you shouldn't have in there. So this is used a good helper extension. And then finally, a good extension, if you're working in VS Code, is the remote development extension, which helps you connect remotely to a DSVM or a dev container. And then a good test explorer. But as I mentioned, if you work in pycharm, pretty much all of these things come from the get-go without even having to configure pycharm all that much. So I tend to use pycharm about 90% of the cases, and then some odd cases I'll go back to VS Code. So once you have a good development environment set up, the next part is writing readable and maintainable code. And as opposed to, for example, C#, where we already have the paradigm chosen for us, we're going to go object-oriented whether we like it or not. Python is a little bit different in that you can choose and pick and mix whatever paradigms you want. So as an example, when you start out, you'll quite often use the imperative style. So this is what you'll use in notebooks, like the more recipe style. Read the data, print the first 5 records, plot the price, and do one thing after the next. Whereas, sorry, not whereas, but if we do this, we end up in a situation where we repeat a lot of the code. We can't test code that's written in this style. So a good evolvement of this is using procedural, the procedural paradigm. So what this does is it encapsulates our code then in functions and modules and things like that. So basically saying that we shouldn't leave anything as raw. Instead, everything should be either a part of a function that's reusable or a part of a module that's reusable. And this also makes sure that we don't use global variables and things like that in Python. And this is quite important when it comes to Python, because if we use global variables and we just misspell them a little bit, since it's not a compiled language, we might be using a completely new variable, and we might introduce bugs that are very, very hard to track down. So at least going procedural is a good choice. If we want to take this one step further, we can also do functional programming in Python, which in Python actually we can't do proper functional programming or pure functions, but at least it allows us to do things like use functional paradigms like reduce, map, filter, and things like that. And then finally, we can also use object-oriented programming. So if we do want to come in from a C# angle, we can definitely also create object-oriented applications. However, it doesn't allow for encapsulation and things like that. But the good thing about this is that we can very much mix and match these. And in terms of data science, using functional programming is a very good thing because it allows you to iterate over large sets of data, whereas object-oriented programming doesn't really lend itself so well to do data science. But all in all, my suggestion for all of these is you mix and match as you want, but do follow like the regular code conventions, like splitting codes into modules and functions, avoiding global variables. And also, as I mentioned a couple of times now, follow some type of code standard. And the basic code standard for Python is PEP8, and also use type hints. If you want to know a little bit more about PEP8, there's a pep8.org which talks about all the different rules, and you can then choose which ones you should or should not follow. As an example of how this looks, this is a piece of code that it's kind of hard to read on first sight, even though it's just a few lines, but this multiplies 2 random numbers. But if we go in and we apply a linter to this, and the linter in this case is flake8, which lints according to the PEP8 standards, it tells us a little bit about what we should be changing, and we can clean this up quite a bit. So we can go in and, for example, clean up the unused imports that it complained about, add some separating lines that it complained about, fix white spaces, remove unused variables, And then it will also complain about things like myfunc, which is not a word and therefore is not a good function name either. So it will then ask us to do something else, and suddenly we have a lot more readable code just by applying the PEP8 standard. And the other thing we can do is, as I mentioned before, also apply type hints. So type hints, the way that works is this. We have a function add, adding a plus b. This can be called with any type of variables, actually. So with ints or strings or lists, and it will never complain. It will just do whatever plus means for that data type. This is quite useful, but also quite annoying, mostly for the caller, because the caller doesn't know what was intended as the input and output, but also because it introduces some quite weird errors if we use it wrong. So for this purpose, from Python 3, you can add type hints. So type hints then allows you to tell the interpreter or pycharm or pywrite extension that we're actually expecting an int, and you should warn me if it's not an int. And in that case, pycharm will then warn us by turning our parameters yellow and saying this, you can go through and do this, but this is not what we intended. So type hints is a really good way to remove some of the pesky bugs in our code. Now, once we have good and structured code, it's time to test our code. So the third learning is around really using pytest, which is one of the more used test frameworks in Python, to your advantage and use it to its full meaning, so to speak. There's really pytest and unit test, and pytest is a superset of a unit test. So right now, most applications that you meet will probably use pytest as a tester. So as per all code, not just Python code, you should follow like a regular test design guidelines. So starting each feature or function by really thinking through what it is that it's supposed to accomplish and what you should test, naming your tests appropriately, writing only the code needed to pass the test so you have proper code coverage, etc., etc. All of those obviously apply here, but specifically for pytest, a couple of things that are interesting is how you can use it. So the first thing, we're going to test this function add. To test it either with pytest or unit test, you would write a simple test case like this. And what's different from other test frameworks is that you have to either start the function with a test underscore or end the function with an underscore test. But otherwise, you just act, arrange, assert as normal. Now, if you have something a little bit more complicated, like this function right here, where you're trying to like you have a function that removes a file if the file exists, you might not actually want to test the OS path or OS remote. These are system libraries that are well tested, and there's no need to test them in your remove file. In that case, you want to do something like mocking, but because Python doesn't have interfaces and things like that, you can't really go through and create another version of this class that only implements your version of this file. So instead, we go through and we do something that's called patching or mock patching. So we say we want to patch OS path and we want to patch OS. And in this case, we want to create a test function that just verifies that we don't remove the file if it doesn't exist. So the first thing we say is we want isFile to always return false. So isFile shouldn't exist, this file doesn't exist. And then we go through and act, actually call this function but every time it's going to call its file, it will just simply return false, not go in and actually do ospath this file. And then the third thing we want to do is we want to assert that we didn't in fact call os_remove. So that is as simple as just do mock os_remove called equals false. So mocking is a very useful thing, is to not have to call into functions you don't own or functions that are not part of this particular unit that you're unit testing. Some other things that are good in pytest are fixtures, and fixtures are meant for you to supply, for example, sample data that you want to supply the same sample data to many different functions. So in this case, I want to test that clean features does something, and I want to test that extract features does something, but I don't want to have to rewrite this whole sample data over and over and over again. So then I just pass in house features as a fixture. So this is similar to a setup or something like that in C#. Something else that's also quite useful, and this is similar to a test case in C#, is parameter size. So if you want to test the add function, then you want to test it with a number of different values. So maybe small values. I want to test that 1 + 2 is 3, and negative values that -1 plus minus, or -2 plus -1 is -3. Then I can use this parameter size, and then I can pass, sort of like call this same test add with a lot of different parameters. Finally, sometimes you have functions that take a long time to run, and maybe integration tests and things like that that you don't want necessarily as part of your automated testing. And in that case, you can use pytest mark to mark some of the tests. And using, in this case, I've used long running, but I could equally just call it pytest mark test and mark some of my tests as with my name, and then say, I want to just run the ones that are marked like this, or I want to run everything but the ones that are marked like this. So that's a useful feature for differentiating your unit tests versus your integration tests or smoke tests. And then once you're done, you would, of course, run them either in the pycharm test runner or in the test explorer. So that was sort of learning number 3, how to run, how to create really good tests in Python. The next one is around automating the boring bit. So essentially, we know that we should write it in certain code style, and we know we want to automate running our tests, etc. But how do we actually automate this stuff and build validations or locally on our machine? One thing that we could use is this library called Black. So Black is a code formatter that will format your code as PEP8 without you having to worry about it. However, it's a very uncompromising code formatter, which means that it will format it and you can't decide how it should format it. So, well, this is good for sort of like my sample demos and everything. I wouldn't necessarily use this in production. Instead, I would use something like auto pip8, which I can configure. And then I would also automate linting using flake-h, which I've shown a couple of times. So apart from my build validation, I tend to do this not only when I submit a PR, but also locally to avoid having to go through the whole PR cycle, fail the PR, build validation, and then have to go back again. So this is not specific to Python, but I wanted to throw this in there because I find GitHooks really, really useful for an interpreted language like Python. So what this will do is it will simply, whenever you do a git commit, it will run Black, and then it will run flake8, and it won't commit unless this worked. So a really good thing to try. Let's see, what was the name of the first extension presented just before Pywrite? I think that might have been the Python language extension. Sorry, you saw that in the chat. Okay, so once we've automated what we want, let's talk a little bit about dependencies. So if you have a project that uses the pandas library, you can either do pip install pandas or conda install pandas, and that will install the latest version of pandas on your system. Now in my first project, I might have this version of pandas, and then I go into another project where they use a completely different version of pandas, maybe an older version of pandas that because they needed some specific feature for it. And then we have some other project where you use like late night pandas, and then you go back to your previous project again and you have to install that pandas again, and so on and so forth, because they're installed system wide. And suddenly you end up in a situation where things get really bad, like you become really, really sad, because all you're doing all day is uninstalling and reinstalling these libraries, and you even end up in a situation where you installed something that completely ruined your whole Python environment. And obviously that is not a good feeling. So how can we make this work sort of like the way that it works, for example, for .NET, where we have a dependencies.json, and we only install that for that particular project? And the answer is something called virtual environments. So virtual environments, you can see them as folders on your system where you install a whole Python environment in a folder, and you install everything you need in that folder. But then when you're done with the project, or when you're done developing this project, you then deactivate that folder. So it goes like this: create a new virtual environment called my environment. You activate the environment. You install requirements.txt. So I'll get into what requirements.txt is in a bit, but that's sort of like similar to your dependencies.json. You work on the application, and then you deactivate the environment. And now you can now go to another project and do the same thing over there. And that way you don't have like conflicting versions on your main system. You can do this also with conda. So conda is another package manager that you can use. And which one you choose mainly depends on your own personal preference. I would say conda is a little bit different as far as a package manager, because it also includes some C libraries and things like that. But both of these rely on something called requirements.txt. So requirements.txt is essentially Python's way of dependency management, which you can, or at least to me, it's a little bit funny that it's a .txt file. It feels a little bit like an afterthought. But what this is a list of the libraries that you would like to install and their versions, or if you don't give a version, it will show the latest one. So you're essentially saying pip install everything that's on this list, and that will install all these libraries and all their dependencies. Now, pycharm has a really good way to deal with these virtual environments. Every time you open up a project or create a new project in pycharm, it will automatically ask you to create a new virtual environment. And it also has good management of requirements.txt. So in this case, you see that some of them are yellow, and that just means that they are outdated. So if we look, for example, urllib 124.2, that is definitely not the latest version of urllib 3. So, and this gives you a little hint of maybe you should be moving to a later version and testing with that. The other thing that pycharm also does in terms of requirements.txt is this. If you haven't installed everything in requirements.txt, it will let you know so that you can install them. And this is quite useful when you're working on a project with many different developers, where someone is now using a new package, they've added it to requirements.txt, and then you're now notified that you don't have everything updated on your system. But the brunt of this is basically to say, please use virtual environments, whether you use Conda environments or virtual env, so you can keep your machine clean and your pandas separated and everyone is happy. My next learning is that to parse arguments with clicks. So a lot of Python applications are really script files that you run from the command line with a number of arguments. So let's say, for example, in this case, you have a function that takes an input file, or a script that takes an input file, an output file, and a debug flag. So typically, Python scripts will use argument parser. That's sort of like the default thing to use, and it's quite nice. It gives good help and all of that, but it does have a few flaws when it comes to maintainable code. One question you might ask is, how would I even test main? For example, how would I test main with different input files, with different output files, with different debug flags? How would I validate parameters? This doesn't really feel very readable because there's a lot of code inside main that just has to do with argument parsing. And the solution to all this is to use click. And this is something that I learned way too late, I have to say. But since I learned it, I just love click. So what click does is, instead of sort of doing the argument parsing inside the function, you use a decorator instead, and you can then split your script up into different commands and tell sort of like what arguments and what optional arguments you have for the script. And what this does is it does a couple of things. Mainly, it puts all the parsing outside of the function, but it also adds parameters then to the function, so that now suddenly you have a testable main function that you can pass different parameters to and call explicitly. It also does a couple of other things to it. You can use custom types and thus do type validation, and it's a lot more readable because your main function doesn't have a lot of argument parsing anymore. So if you learn nothing else, and if you haven't used click, I would say this is like the #1 tip. The next step is around embracing Pythonic Python. And I think this is true for any language that you work with, whether it's Python or C#, that you should spend some time looking at really good native code and what good developers are writing in the native language, so that you can use, in this case, the Python way of doing things, both because they allocate memory better, because they're faster usually, but also because they become a lot more readable if you do things the Python way. So some examples of this. Let's say we want to square some numbers. So we have a list of numbers that we want to square. And the C# way of doing this would look something like this, like a while loop through all the numbers and appending like number times number. But this has some issues in here, that we have to sort of iterate over this, or we have to increment this variable I. That's actually not even needed, but we have to do that in order to pass on to the next value. So a better way to do this would be to use a for loop, and then we wouldn't have to worry about maybe running into like an infinite loop or something like that. However, this is using the for loop in a very C#-y way, thinking that the for loop in Python is actually a for loop in C#. But it turns out that in Python, the for loop is more related to the for each loop in LINQ. So a more Python way, or a more Pythonic way of doing this, is to say for num and nums, just append num times num. And then we've sort of like removed the indexing, and we've also used it as it should be. But an even more Pythonic way to do this is by using list sorry, it didn't slip my mind what it's called, list comprehension. And this is a way to write a for loop inside the list itself, just to get it as a one-liner. So this will create a list of num times num for all num in nums. This also allows things like filtering. So now it will just create a list of the squares of the numbers that are even and not the odd numbers. And we can get crazy with this. We can have like nested for loops and things like that. And we shouldn't really go that far. In that case, we should definitely go for a for loop instead. But if you just have a simple case, this becomes much more readable and much quicker to read if you don't have to sort of like flood your code with unnecessarily loops and things. Another example, let's say we want to sum all the numbers between 10 and 1,000. So this again is a typical way to do this, maybe C# style, but then using the built-in functions in Python, we can instead write this a lot simpler. Like total sum is the sum of all numbers in the range from 10 to 1,000. And finally, another example is this item in the list. So Python does a lot of list processing. So finding an item in a list is a very, very common thing in Python. And this would be a totally valid way to do this, but a more Pythonic way to do this would just be to write found equals sherry and fruit, or if sherry and fruits. So spend some time and look at a lot of Python code and spend some time on sort of figuring out what the Pythonic constructs are. And there aren't too many, so it doesn't take a whole lot of time to actually go through and get better at writing Pythonic code. Now, the next tip is on how to keep your secret in Python. And one good way that I found and that I use quite a bit is with environment variables, and specifically with .env files. So this is an example of an environment variable file that you can just have in your project. And what will happen if we go through and load it up with .env is that it will mix and match whatever is in the .env file and also in my environment variables, in my system environment variables. So this is quite a useful way to, for example, save my secrets, but also to have different configurations in different environments, like in production or dev. For number 9, I've saved the notebooks to be or not to be. And I started out doing a lot of notebook work. And in fact, like the first year of working with data science was mainly in notebooks. If you're not familiar with notebooks, this is how they look. So in notebooks, you can mix and match code in code cells along with things like Markdown or LaTeX. And the cool thing about this is, of course, that you get sort of like you build a story and you can get a lot of diagrams. It's a very good way of browsing through large amounts of data and representing them nicely and sort of creating like a story around your data. And if you haven't seen this before, and if you come from the C# world, then there's also the same thing actually available in C# now. So you can use notebooks in both C# and F#. So for a long time, I thought this was the way to work with data science in Python until I had to put something in production. And I realized that working in notebooks it's not really that production friendly, to be honest. First off, the code structure is very difficult to get a good code structure. It's very difficult to get good code reuse and things like that. For example, putting reusable code in functions and including them in notebooks. You can also run cells out of order. So I could, for example, run cell 1, cell 3, and cell 4, and end up in a situation where like someone looking at the notebook after me had no clue how to reproduce what I saw in the notebook. The other problem with notebooks is that when you put them in source control, they contain both the code and also the information about what the run, like how the run went, so the output of the run. So that means that if you run it and then you run a few cells out of order and then you git again, you'll have a different git than the previous person that ran it. So it becomes a little bit hard when a source control diff isn't really a code diff, but actually a run diff. So that is not a very nice thing. The other thing is debugging code. And I know that there is some tries now with debuggers for notebooks and things like that, but that's still very kludgy compared to debugging code in a py file. And testing code. Again, some people are trying it out, but it's sort of like an after the fact thing, and it's very difficult to test code in notebooks and to lint code in notebooks, or to even set up like a CI/CD pipeline. So my suggestion, if you're working with notebooks, is to work with notebooks while you're exploring and experimenting, but then keep them as a private thing, used for experimentation and exploration. But if it's going into production, it needs to go in a py file. And if you made a good report, instead of just leaving it as a notebook, then save the output as HTML and PDF, because if someone else runs the notebook, they will have a completely different view of what happens. And some people might say, well, I'm using notebooks because I want to have an interactive environment where I experiment. But it turns out that both pycharm and VS Code can run interactive sessions inside pycharm and VS Code themselves. So by just adding these hash mark %%, you can create your own cells in .py files that you can run one by one. So when seeing the output. And actually in pycharm, there's also a very good way to look at data sets and things like that if you have the pay version. Finally, as number 10, putting it all together, and I will suggest using a cookie cutter project structure if you don't have your project structured in any other ways, because a lot of Python projects end up a little bit like this, like a big pile of files. Like you have clean dataset.py and then a clean dataset too, because you changed something a little bit, and maybe you version it because, I don't know, it was different this day, or maybe I gave it like my initials and -1, and then I created like a super final version of this cleaning script because this is my way to do versioning now. I don't trust Git anymore. I don't know, but this is like what you'll see a lot when you're coming into someone's data science project. And instead of doing this, I will suggest to start off every data science project or other projects well from the beginning and not let it get to this point. And for that purpose, the cookie cutter data science project is a very, very nice starting point. So the cookie cutter data science projects, I'm sure you've heard of cookie cutter before, maybe in other constellations. So cookie cutter is just a way to create a template for a project. And you can create templates for C# or for Python or Go or whatever you want. This particular cookie cutter data science template is how you create like a good starting structure for projects that have to do with data science in Python. And it's very, very opinionated. It's opinionated about how you should store your data. It's opinionated about how you should use your notebooks and how you should keep your secrets and all of that. But it also gives a good starting point, so you don't have to remember all of these last 9 tips, because you get them for free just by using the cookie cutter data science project. So it looks like this in the structure. So it structures your data as far as your raw data and your process data. It structures your code in a very nice way. It structures your documents. It talks about like how you should actually name and structure your notebooks and where you should store your reports, etc. It already has things like the requirements.txt built in, so you don't have to worry that you forgot about that. It worries about how you should store your secrets. And it even has in the setup of your virtual environment. So you have that taken care of, and also so you can have parts of the projects be packages that you can reuse in other projects. It fixes things like it uses Click, it uses Flake8, it uses pytest. It does use a few things that I don't use on a daily, like Tox and Sphinx for documentation. And then I specifically added 2 things to this that I like, both a pre-commit, but also a test folder where I add all my tests outside of the source folder, because I don't think that tests belong in the source folder. So those are essentially the only 2 additions that I make to this, and this is a project structure that I start most of my projects with. And finally, one thing I don't like about it is that it doesn't have a choice for AWS or Azure or Google. It picks AWS by default, but you can definitely use it whether or not you're using AWS. You can just ignore the initial settings for your AWS setup and instead add the Azure or Google equivalents. So to use this, you just pip install cookie cutter, and then every new project you want to start, you just do cookie cutter and then use this template. And I want to say use a cookie cutter project structure because other people will thank you. This is sort of like their slogan, but I will come and thank you personally if you use a cookie cutter project structure, because it makes such a big difference coming into a project where the structure was set from the get-go, or the repo structure was thought through, versus using one where it wasn't. Now, those were my 10 sort of like big learnings. I hope you learned something from them. I do have an extra bonus, which is a little bit a reason why Python is actually such a good language for machine learning and data science, because there's always a package for everything. And I think as a Python developer is a good learning that there is usually a package for everything, and that you don't necessarily have to rebuild or reinvent the wheel. But I also want to put in a word of caution that if you use a package that's out there, just make sure also that, just like if you would use a NuGet package, that it has enough downloads, that it has an open source repo. So in the case where you add this to your Python or to your production project, and somehow that project gets lost or whatnot, that you at least have the option to fix bugs or rebuild it if you need to, so you're not stuck. So it has libraries for plotting. This is plotting with Seaborn. It has libraries for creating neural networks, which is one of the few languages where you can actually easily create neural networks out of the get-go. So if you've never seen a neural network in code before, this is pretty much the only code you need to create a neural network. This is Keras. A few more lines to compile it and things, but this is how uncomplicated the code looks for writing a neural network. What's really complicated about training a neural network is actually the data that goes into it. So it's not necessarily the code, but much more the data and thinking about that. It has libraries for pose detection, or in this case, this is actually a little interesting library called optical flow. So optical flow, specifically if you're working with images or video, what it does is it takes like a pixel and it follows it through the video. So let me actually run this. This is something that's included in the OpenCV library. So what this does is it follows a few different pixels in the video, and what you get out of this is vectors and things about how these things moved. So if you want to create anything that's based on how items move in a video, like for example, a machine learning model based on this, this is a package that already exists and you don't have to rewrite such a package. Or something like, you're just doing simple object detection, you don't need to retrain a model yourself. There's already pre-trained models that you can use, and this is the amount of code that you have to write to figure out that there's a person in this picture and there's a ball in this picture. Or something like background removal. So this is also something from a machine learning project that I was working on, where I'm going to run this into just a second. So what this does is it creates a mask for the background so we can focus only on the people in the picture. And this is not a machine learning library, but a simple sort of like what pixels have changed since the last frame. So it works well for steady cams, but it doesn't work well, as you saw, when the picture is panning like that. But all of these libraries are already there, and you don't have to sort of like reinvent the wheel and implement these algorithms, which is quite useful. And this is also the reason why we do machine learning in Python and not in C# or something else usually. So that was a summary of my learnings over the last 4 years of Python. So setting up a good environment, creating or writing good structured code, testing, automating everything, setting up virtual environments, using Click for parsing, writing Pythonic Python, storing your secrets, and to use or not to use notebooks, and finally structuring your projects. So with that, I just want to say thank you so much for listening, and I'm not sure if there were any questions.
There are quite a few, so
Okay.
Thanks. First of all, thank you for a very interesting session. I've actually never looked into Python in too much detail, so I learned quite a few things there.
Okay.
So yeah, let's now maybe go over a couple of the questions that are there. One of the questions, actually a couple of them, were around extensions and packages. So let's maybe get those out of the way first, if you can quickly go do them. One is what the first extension that you presented was just before PyWrite.
Yeah, and let me see if I can actually move back to, I know I'm showing my background right now, but let's see if I can do this. Okay, so I think these are the extensions that I use. So the first one is actually called Python. It's a Python language extension. So for Visual Studio Code, you essentially have a language extension for each language that you use.
All right, cool. Yeah, another was around the library that you used, or the module that you used to store secrets in that cookie cutter project model.
Yeah, so that's called load-env. So let's see, we're moving. It's called load-env or .env, but there is actually a number of different ones. Sorry, I wasn't really. Yeah, it's called .env anyways.
Yeah, okay, cool. Then another one was around, is it possible to use some dependency injection and IOC stuff in Python, or is that not a Pythonic way of doing things?
Yeah, so that's actually a very interesting question. We're investigating that in our current project. And yes, there is definitely ways to do dependency injection. You don't have interfaces, so it becomes a little bit difficult in that sense, but you can do dependency injection. The question number 2 on that is that not a Pythonic way to do things? No, it's not a Pythonic way to do things. And I'm kind of opposed to using dependency injection for that matter in Python, but I'm also interested and willing to be proven wrong. I can't hear you, so I'm not sure
Yeah,
if you're
exactly.
muted.
I was on mute. Yeah, another one was, what is the best way to integrate C# and Python? And my follow-up question to that would be, would that be something that you would want to do?
So that is also interesting. This is something that we're also investigating in our current project, mostly because we have a situation where we have to run some C++ things on the edge, on where we're using our machine learning models. And yes, you can integrate them using Python, for example. And sometimes, actually, it turns out that it's sometimes faster to work with Python than regular Python. In fact, quite a bit. But it also introduces a lot of overhead. So there's a lot of template code that's generated by converting Python to Python. So it depends a little bit on, we haven't really discovered yet if we think it's a good idea or if it's going to cause problems if there is a bug, for example.
Yeah, and related to the same thing, would you use ml.net for something in C# and then combine that with Python, or is that also
Oh, sorry, yeah, so sorry, I think I answered the wrong question before. Python is for C++ and Python, not C# and Python.
Yeah.
I'm not sure if there is a combination of C# and Python. In fact, I don't think so. And as far as like, would I use ml.net combined with Python? I haven't tried it. I can see that someone might want to do that, but Python has so good machine learning libraries and things that you don't necessarily need ml.net. I would see ml.net more as something that you would use if you didn't want to use Python.
Yeah. All right. One more, or at least 3 more even. One is, when do you feel notebooks are actually useful? Is it only for learning purposes, or is it also for the usage scenario where you would use a tool like LinkPad, for example, in .NET world?
Yeah, so I use them actually in the beginning when I'm exploring data. So when I'm looking at things like how is the data distributed, like for example, like yeah, bringing up a bunch of plots and diagrams and things like that. I find it really useful for that, and I do use it for that. But anytime it moves over to something that goes into production, like creating your models and things like that, I no longer use it. But I do think that, and I don't work with this a lot, but for example, with Databricks or Spark, you might need notebooks there.
Yeah. Cool. Yeah, and then a final one, which is actually 20 questions wrapped into a long, elaborate question. And that is, how hard would you say learning Python is? If you come from C#, what could people expect before they feel confident in the language? And also, on top of that, would you have any book recommendations or resource recommendations, 1 or 2, where people
Yeah, absolutely. So I think like reading Python is super easy. Like you can do that now coming from C#. That's not a problem. Like the list comprehensions and things like that, it look a little bit odd, might take a little bit longer, but C# is a much harder language, I think, than Python in that sense. But it's also one that's a lot more, like I like C# in the sense that it's a lot more structured. So when you write something in C#, you're less likely to shoot yourself in the foot than with Python. So writing good Python takes a while. Writing Python takes 0 minutes, if that makes sense.
Right.
And as far as recommendations, so Dan Bader, D-A-N is his first name, and last name B-A-D-E-R. He has a lot of both blogs and things like that for, you know, Python nuggets, like getting started with Python. But then there's like a lot of, you know, getting started programming schools on the web. And for machine learning, I really like Deep Learning with Python by Francois Chollet, the author of Keras. So if you're interested in that, that's a really good book, I think. And Machine Learning Mastery also, and that's a blog if you're interested in the machine learning part of it. But Dan Bader, I think it's called Python Tips and Tricks.
Cool. All right.
Yeah.
Thank you very much. I guess we can wrap up here. I think people should have your Twitter handle. It's basically Tess's name with an @ in front on Twitter. So if you have any follow-up questions or comments or feedback, feel free to reach out on Twitter. With that, thank you again, Tess, for presenting.
I appreciate.
Lots of great feedback in the questions pane here as well. I'll share that afterwards.
Cool. Thank you so much.